about some of the volume of missing assignments. Are you doing work for each one of your classes after these Google Meets?
Yeah.
And are you submitting them?
Some of them don't tell me to submit. It's just I do them and then they don't submit to the thing.
Okay, because we want to get on that sooner rather than later. So if you're working on an assignment, there should always be an option to submit, whether it's through Cami and there's a little button in the top right corner where you click submit, or maybe they're giving you instructions to take a photo and upload it, and then you should submit. But if you're not seeing a button to submit it, just like Miss Noel shared a moment ago, reach out to the teacher, send them a quick email, or call us here at the school so we can find out what the issue is. The last thing I want is for you to have, 10 assignments that you're behind on and you feel like you did it, but then none of the work was saved or none of it was submitted. Okay.
Well, we
Okay.
did figure out one problem before I think you popped on. Her courses weren't showing in her dashboard. And so I stepped her through to choose all courses and put the little star by them. So
Okay.
now she sees them all because she wasn't seeing mine or math. It had kind of disappeared for some reason. And now
Okay.
she sees them because we activated that star.
Gotcha. Okay. Well, that helps. That makes it so that she's at least able to get into the courses. But again, Amaya, if you run into an issue of you're not sure where the submit button is or what exactly you're supposed to do to submit the work, make sure that you're contacting your teachers.
And
And
if
the
you
other, the other thing to keep in mind is check your grade books every day. Or on your dashboard down at the very bottom, Amaya, there's a link for you to check your grades. Click on that so you can see what's in the teacher's grade book, and you'll see what's missing for me. And if you think that it's something that you've already done, that you tried to turn in, but it's showing missing, well, then that's another reason to contact the teacher and say, hey, I thought I submitted this. Can we meet real quick to figure out what's going on?
And if you can't find a submit button, if you take a screenshot, it's control and the little button above the number 6, and send that to your teacher. That'd help us be able to see what you're seeing.
Okay.
So, all right.
That's this one. You guys keep going with your science.
All right. I think I've got everything set. I just got to keep an eye on my board because it goes to sleep and then it messes everything up. All right. So I think, I don't know if you were typing as we did it or wrote along, but this was the test tube, the beaker, the test tube rack. We're going to call this the pestle and mortar and pestle. I don't think that's the correct picture, but that's what we're going to call it. And this is a flask. So that's what you're going to do every day. This is kind of our warm up for here at school, our bell ringers. So we'll be doing those here at school as well. And we usually do them together. And like I said, it's just a way for you to get extra credit. So if you have those missing, you're not going to be able to go back and do them. But if you've been on or if you've got in touch with me and you weren't on a Google Meet, then I was able to give you attendance credit. So let's go back to modules. Modules is where you want to always go. A lot of students want to go and just look at the to-do list or assignments or something like that. But there's always stuff here within the module that can help you. So like yesterday, there was a little lab safety demo. So if you would go back, because you only saw part of it, and watch that lab demo that I did, there are 5 questions. And if you watch it, you'll be able to get those 5 questions, and it'll be an easy little grade to go there. Any of these that have the little eyeballs on it, it means it's something that you need to look at or read. And this is where I'm going to put all my meet recordings and my PowerPoints. So we're going to move down here to measurement notes. And so many of your teachers will use Kami. And if you're not familiar with it, the submit button for Kami, when it loads, is right in the document. So once it's going to be up here, the word submit. And so after you have typed in here with Kami, you click on the text box and you click, and it puts in a text box there for you to type in. Once you've done that, you click submit. It brings down a drop-down window, and I think there's one more submit button. that you can do to get that submitted. So many of us use this. So that's an easy way to submit. And I like to put my PowerPoint up here so that hopefully you can look at it while you are working on your the notes. I wish there was a way I could put it side by side, and I haven't figured out a good way to do that yet, but this is the best I can do to have it on the same page. So you're welcome to kind of open a tab and get this open, and you can type along as I go. And if you know how, I can't do this because I did a window present, but you can drag a tab out and make it smaller and have it on one side and have your other tab maybe with me showing the PowerPoint on the other side, and you can type while I'm going over the notes. So that might be helpful, or you can wait till I post the video and watch it that way, or you can work on it afterwards. But I'm going to go through this set of notes, and it's going to involve some math. And if you need to use a calculator, in your math class, they should be showing you how to access Desmos, or you can just Google an online calculator for when you're at home. So we're going to get started just with measurement. Some of this I hope is a review. In the first part, I tend to go over a little bit of vocabulary. And so a term that we use a lot in science is accuracy. And that is the degree that which your experimental results, so what you get in the lab, will agree with what is accepted. So if I have you measure the length of the table here in class, you should get the same value as I got when I measured it. So that's what they're meaning there. So how correct it is. Precision is if everybody in class made that measurement, they should come very close, if not exactly what I got. So that's precision. So measurements agreeing. So they're being sort of consistent with multiple measures. And then meniscus, if we're able, when we're face-to-face, to use graduated cylinders, water tends to make a curve here, and we call that a meniscus. And you can't read it on the edges because it comes up higher. You have to read it in the center of the curve. So we would say that that's 20 milliliters. So with accuracy, we went over that already. I'm not going to repeat that. Here's a nice diagram. So we have precise and accurate. So with a bullseye, if you hit, and these dots come out a little bit so you can see that we're trying to hit the same spot. They would look like one dot if you actually did hit the same spot. So if you hit the same spot in the bullseye each time, that would be precise and accurate. If you hit the same spot, but it's outside the bullseye, like right here, it's precise because you're hitting the same area, the same spot, but it's not accurate because expected is the bullseye. In this one, you're getting accurate each time, but you're not getting precise because you're hitting the bullseye, but you're not hitting the same point. And then this is neither. So that kind of gives you a visual of what we mean by accurate and precise. So if in this example, a student knows 85% of the material for the test, but when she takes the test, she scores 70%, is this going to be accurate, precise, or neither? So if it was accurate, it would be, I think, the exact same one, and it would be neither because it's not anywhere close to 85. 70 is too far away from 85. So it would not be either one. But if Miss Joyner's dog Millie is known to weigh 65 pounds, she has weighed that consistently every time she's gone to the vet. But then when she goes to the vet, it is weighed. She gets these measurements here. So are these particular measurements here, when we compare it to this one, accurate, precise, or neither? Well, these three measurements are very close to one another, so these three measurements will be precise, but they do not match this, so it is not accurate. So precise, but not accurate. And then average is a simple math skill for math. You're going to add up everything. When you get that total, you're going to divide it by the number of items that you added up, and you get an average. So that is an example of average. In science, it's very important that we use a standard. If scientists across the globe used different standards to measure, we couldn't compare our work very easily, especially take all the work that was done on the COVID vaccine. If the scientists in Europe used a different measurement than the scientists in the US, we couldn't share data. We wouldn't have very accurate or precise data. And so standards are very important. So scientists use something called the SI system. It was developed in France, and so it's called System International. And it is what all scientists use so that we can compare and talk about our data very easily. Each unit that we use, or each type of measurement we do in science, will have what we call a base unit. And then we use prefixes that are multiples of 10 to make it easier. So here are some base units. For length, which is the distance between 2 points, we're going to use the meter, and you're going to see it represented with an M. Notice it's just a single M. And you're going to use a meter stick or a metric ruler that has millimeters or centimeters on it. Mass is going to be the amount of matter in an object. So we're going to use one of these types of scales here, or a triple B balance. I like to call the base unit as gram because it's just a single G, but because a gram is so small, they bump it up to the kilogram, which is equal to 1,000 grams. But we generally will be using just the gram, so I like to change that to gram. If we're measuring volume of an object, which is the space it occupies, we tend to use liters, and we do a capital L so it's not confused with a number 1. If it's measured in a graduated cylinder, it's usually liquid, or we're using displacement, or we can calculate it if it's a geometric equation, a geometric shape. We can use a mathematical equation. And then time, we use seconds, so S. And be careful anytime you write an S, make sure it looks like an S and not a number 5. And stopwatches are used there. Remember, with the graduated cylinder, we have the meniscus that we read it at. And temperature in science labs with true scientists, you're going to use Kelvin, which is K. But we're going to use Celsius, which is in the metric system. It's just easier for us to have and to measure. And in the US, we tend to use Fahrenheit a lot. So we're going to look at how we can convert between those two. Temperature conversions. These equations right here, you're going to need, and I'm going to jot them down so I can put them on another slide in just a minute. Anytime you use these conversions, I will actually give Sorry about that. I just kicked myself out. trying to write these things down. Can you hear me now? All right, I'm going to jot these equations down so I can put them on the other paper. And we're going to look at how to do some of these. So again, I will give you these if you need them for anything. So in this example, Miss Smith is going on vacation to Greece, and it's predicted to be 27 degrees Celsius. But she lives in the US and she doesn't know what to pack for this type of weather. So she needs to convert this to Fahrenheit. So we know Celsius, we don't know the Fahrenheit. And so we're going to use the Fahrenheit formula because that's what we're looking for. So all we're going to do is we're going to put 27 in for the C here. That little asterisk means multiply. And to multiply, if you would take the 27 times 9 equals and then divide by 5 is the easiest way to do fractions. You get this. You add the 32 to it, so we know that it's going to be 80.6 degrees Fahrenheit. So that is how you would do this. So I'm going to clip over to my Jamboard here, and we're going to do these together. And so you're going to want to work on or to do these on your notes where it says practice time. And so you may have to come back and look at my video if you're not doing it with me. So for number 1, I am given Celsius, which is 23. I do not, it says 2 Fahrenheit, so I want to know Fahrenheit. So that means I'm going to look at my formula, and I wrote them on a piece of paper so I can remember them. I never can memorize them. So I've got Fahrenheit equals degrees Celsius times, I'm going to use a dot, 9/5 plus 32. So I'm going to put 23 in. Oops, 9 times. So on a calculator, I'm going to go to, well, get my calculator up. I'm going to say 23 times 9, that's 207, divided by 5 plus 32. Now I'm going to divide 207 by 5 is 41.4 plus 32. I'm going to add 32, and you get 73.4 degrees Fahrenheit. You don't have to show every step that I show, but you do need to show the equation you're using. You need to show how you plugged in, and then you need to at least show the answer. For some students, it's easier if I show step by step. So number 2, we're given Fahrenheit. So I'm going to put number 2 right here. Fahrenheit equals 48 degrees Celsius equals, we don't know. So I'm going to use my formula for Celsius. Degrees Celsius equals 5/9 degrees Fahrenheit minus 32. So I've written my formula. I'm going to fill it in. So 48 goes in the F minus 32. I'm going to do what's in parentheses first. So I'm going to go 48 minus 32. I get 16. So 5/9 times 16. I'm going to do 16 times 5, which is 80, divided by 9. Then I'm going to divide that by 9 in my calculator. And if I get a decimal, put at least 1, if not 2 decimal places. I get 0.88888. So I'm going to do 0.89 degrees Celsius. And then I'm going to need to erase some. So let me get my eraser over here. I'm going to erase number 1. And I'm going to put up number 3. And then that's probably as far as we're going to get today. So we're going to do number 3. So I'm given 83, which is degrees Fahrenheit. And I want to find Kelvin. This one is a more difficult one because my Kelvin formula has Celsius, so I have to convert 83 to Celsius first. So I'm going to do Celsius equals 5/9, 83 minus 32. So I'm going to do 83 minus 32. That's 51. So 5/9 times 51 times 5 divided by 9, I get 28.3. So I'm going to take that, and for my Kelvin, it is degrees Celsius plus 273. So I'm going to take 28.3 plus 273. So I'm going to add 273, and I get 301.3 K. All right, that's as far as we're going to get today. So if we go back here, oh, wrong one. If we go back here, you will complete your notes, and if by some chance you have to authorize your Google Drive, you do so. You just click and choose your email. You will work on your notes, and it will. You don't have to save or anything. It automatically saves, but you can work down to where I did this right here. You can stop at prefixes, and I will have that uploaded tomorrow. We don't have a live Google Meet tomorrow, but I will have one recorded for you to be able to get this information. Then if you go back to modules, if you want to go ahead and work on the temperature stuff, if you click where it says metric temperatures and conversions, metric and temp conversions, notice that it says on the first page, do odd only. So for temperature conversions, you're only going to go through and do the odd ones. So you're going to do number 1, number 3, number 5, number 7, number 9. So those are the only ones you're going to do on this page. And you can go ahead and do that. And then the rest you will do tomorrow, because I will make this final due date change to probably Friday the 15th. So you'll finish that up tomorrow. Any questions?
No.
Okay, so tomorrow we will not meet. I will record a recording and we'll put it on. Let me go back here so you'll know where to look. The same places I put today's, I will put it. So come down here, right here. I will also put Fridays because it still goes along with measurement. It's just going to be 2 days. And you can go ahead and look at these videos if you want, but I'm probably going to move them over to Friday so that it's just work on your notes and just the first part of the temperature activity here. If there's no questions, then that is it. And if you can make sure, if you have time to go back and do a couple of the makeup assignments. If not, we'll look at getting a time together once we're back face to face where you can stay after and we can get you caught up.